Hi students, welcome to Science Extension and Module 3, the Data, Evidence and Decisions. This is the final video in IQ2 and we're going to try and bring together some of the discussions that we've been having around statistical testing and what you're going to do with those statistical tests in order to not only analyze your data but also come to conclusions around your null hypotheses. So video 19 is about applying statistical tests to our data sets. As we go through each of these, the important thing is that you can learn to apply appropriate performance measures to the statistical analysis of a data set that is relevant to your scientific research project. So as we go through each of these, and you're going to be at different stages when you watch these videos, you're going to be needing to think about the sort of data that you're collecting, the sort of conclusions that you want to make, the relationship between the variables that you think exists, that you've hypothesized might exist, and what sort of testing you're going to need to do in order to establish rejection or acceptance of your null hypothesis. So we want to try and summarize our statistical tests. So I'm giving you two ways in which you might be able to do this. The first is to summarize the tests in a table. Tables are a great tool for comparison, for looking at how you might ensure that you've kept all of the data that you need on a particular question, or that when you're trying to memorize important information, that you use tables because there's a cell in each of these tables, and if I leave any cell blank, it very obviously says to me, I don't have information about that. It's also a good way that you can use to answer some questions because, again, you're making sure that you've addressed all parts of a question if you've got all cells in your table complete. So you can see we have a rationale, a question, if you like. What question am I going to ask of my data? What data do I have? Where did I source that data? Where did it come from? And then what statistical test am I going to apply, and how do I interpret the results of those tests? So the one important thing we've been talking about all the way through is means, when we're comparing means between two different groups, and that's going to depend on whether we have one independent and one dependent variable, or how many conditions we might have for our independent variables, and possibly also whether or not the individuals or the subjects that are part of one group are also part of a second group. Sometimes our samples will be independent of one another, and sometimes they'll be paired. When they're paired, it makes sense to do a paired t-test. So if you're looking at the effect of some intervention on the results, say the science results of a particular group of students, and it's the same group of students, you do something initially and then you test them, and then you do something afterwards and then you test them again, and it's the same students, then we're talking about paired samples, and so we're talking about a paired t-test. If the means that you have come from independent samples, so for example if you're counting lollies out of lolly bags, those are independent bags, independent lollies, and so they're not a paired t-test this time, they're more of an independent t-test. Either way, if you're using your t-tests, you're looking for a p-value to be less than your alpha value, which is our 0.05. And when we do that, then we can reject the null hypothesis and actually infer or conclude that the mean of one group is not equal to the mean of the other group, and it's higher or lower depending on what that alternate hypothesis is and what we've been investigating. If we're interested in means, but we want to know something more about the population, about the variance that is associated with those means, then we're starting to talk about analysis of variance. This is where our F-test comes in, or perhaps more involved test would involve an analysis of variance, or an ANOVA. And again, I think analysis of variance is beyond the scope of this particular course. But of course, if you are collecting data and it makes sense for you to look up how to carry out the ANOVA, again, we've done a lot of these in Excel, and there's heaps and heaps of statistical tests in Excel. There's way too many for us to look at. We would have to do an entire course on statistics to go through all of those tests and be able to apply them appropriately and confidently. So we're trying to sort of trim this down to the basic necessity of what it is that you need. But again, if the p-value is less than 5%, then we're going to conclude that the two variances are not equal. If we've got frequency counts, and if we've been able to set up a situation where we can think about some comparisons between observed and expected values, then we might be in a position to use our chi-squared test. The interpretation here is around the degree of association of the samples, and once again, we can still use the same sort of logic to accept or reject our null hypotheses. And finally, if we're looking at the relationship between two different variables, if we simply want to know whether or not there's a degree of correlation, how similar the values are in terms of their relationship between each other, then we can look at this Pearson correlation coefficient to determine whether the samples are correlated. If we're trying to go a little further into the causation, or we're actually looking at the specific effect of the change in the independent variable on the dependent variable, then we might be looking at something like regression analysis. So just a simple linear regression in this case, and again, that might give us something more in terms of our confidence intervals and the ability to accept or reject our null hypotheses. Bill Matchett, in his textbook on science extension, has put together a little flowchart, and I think flowcharts are a nice way to start to get a bit of an idea about how to answer these questions. So the same sort of information that you just had in a slightly different way. Are we looking at categorical or numerical data? Most of the time, if we're looking at categorical data, we're thinking about our chi-squared test and our observed versus expected. If we're looking at numerical tests, then basically we're looking for testing two means or relationships between two variables. If we're looking at the relationship between different variables, then we want to know virtually something about the strength and direction. Is it positive or negative relationship? And how much strength or confidence do we have in the association between the variables? Then we're looking at Pearson. If we're interested in the linear relationship and that specific causal relationship between our response variable and our explanatory variable, so our response would be our dependent variable and our explanatory variable is our independent variable. If that's what we're after, then we're probably looking at a linear regression test. And if we're testing for means, then we need to think about how many treatment groups we've got. If we've got more than two, then we're analyzing variance and we're thinking about our F-tests. We can use the F-test with just two groups as well, but it has more of a focus on the variance in the samples rather than the comparison of the means. But if we are comparing means and there are two different groups and the groups have subjects that are the same in both groups, then we're looking at a paired t-test. And if they're not the same, then we're looking at an unpaired t-test. These sorts of flowcharts are probably a good way to just put up somewhere, keep in front of you, so you are constantly thinking about the different types of statistical testing that you're going to be doing. And of course, most importantly, you need to make sure that you think about what's relevant for your own study, for your own research project. Which ones are you going to use? How are you going to determine whether or not the values that you have are significant, and or how you're going to approach your null hypotheses? Will you accept the null hypothesis or will you reject it? This brings us to an end of this second part of Module 3, and I thank you for watching.